Hello, and welcome to this short little sort of update on the model railway project. In this one, I've just started working on trying to get some sort of move from one single line to points and stuff, and with DCC and everything. I've never used it before. Don't know anything about. Well, I know about it in theory, but I'm just trying to put the theory that I know into practice. So what I'm going to do is try and make a point work with the DCC controller. It's a bit of an experiment. I've watched videos and everything, but all the videos that I seem to see are for 00 points, and I can't find a video on the ones that I've got, which are N-gauge points, and the Pico ones ST5 and 6, the little short points, and underneath doesn't look the same. So I applied a little bit of logic that looking at the metal and stuff and where current would flow and this, that and the other, and I'll talk you through what I've done, and we'll see what happened. Just quickly before we go and have a look at what I did and what happened and stuff, if I've done something wrong or there's a better way of doing it, can somebody that's in the know let me know, because obviously I'm all on my own down here, and I've only got YouTube for company, so in relationship to model railwaying, that is. So like I say, I'm just hunting around trying to work stuff out myself, so if there's a better way of doing it, can somebody let us know? Alright, cheers, thanks. So this is a Pico ST5 or 6, I don't know which one it is, but it's one of the ones that comes with the the starter Pico track. It's a very, very short point, very, very tight radius. I think it's a 9-inch radius this. I'm using these on the bit where I'm actually loading trains onto the layout. I'm going to be using the code 55 points and express points and all that, the longer points. I think they'll look better on the scenic part of the layout, but these are just behind the backboard, you know what I mean? So they're just throwing the trains from one line to another as I load them on, and I've got a few of them. Anyway, now as I understand it, I can't use them out of the box on DCC. I have to do a bit of fiddling. So if you turn it over, this bit here, there are two wires. There's one joins from there to there, and one joins from there to there. Well, I'm going to have power coming up this rail. I'm going to have power coming up this rail. Now, obviously, when you throw the point, you're going to be taking power from there up there, and power is going to be there, right? Problem is, at some point, I'm going to be having the wrong power going to the wrong place, I think. The other thing is, of course, these wires are insulated, so as they cross, that'll cause a short. So I'm going to keep the bottom wire in and take the top wire out, and then with the top wire, what I'm going to do is cut there and solder a wire from there to there, and then cut from there to there and solder a wire from there to there. So I'll have power coming from this main rail to here, and from this main rail to there. Obviously the power will, on this wire here, the power will go right up. So at this point on my little test, I'm going to have to power this rail from the DCC controller, because there will be no power going to this rail because it's an insulated frog. So I'll just show you in Blue Peter style what I did earlier. So there you go. I've cut that wire out, I've left that wire in, and I've soldered, I don't know whether you can see it particularly well, but I've soldered a wire from there to there and a wire from there to there. Now this is my second bit of soldering that I've ever done, and I sort of melted the sleepers a bit and stuff, but it doesn't matter, it's a bit scrappy, because if I do actually use it, it's in a hidden part of the layout anyway, so nobody's going to see it, but it was a useful experiment. I learned a lot. So let's go and have a look at how it goes and what happens, see if it works. So let's try it out. Let's see how I've done. If you remember in theory, okay, I've got power coming up this line. Okay, it'll go straight across there. There's that wire that I left in. Should carry on power through there. Obviously we've got power coming up here. And then I've got those joins there, from there to there, and from there to there, feeding power to this part of the point. So at this moment, power's been fed from that rail to there. Now, when the point's thrown, this power should carry on around this corner here. Yeah. This power will go up to there, but it will stop there because I've got no joiner from that wire to that wire, which is why I've got put this wire here. It's just touching power from the main feed from the ECOS. So that's the theory. So let's start a train up and see what happens. So at the moment the point's going right the way across, so the train hopefully should go all the way through. So here we go. And it works. Right, so that's fine. I'm quite happy with that. I'll just be able to get around quicker. Right then, slow it down now. Across the point. Now hopefully I should have power going up to that spur. There we go, it just chucked itself off the end of the line, so at least I know now that my little bit of soldering experiment worked. Okay, right, I'll show you something else as well that I'm experimenting with, see if you can see if it works or not. Right then, this is 1mm cork that's been rubberized. So it's a rubberized cork. Now I think it actually makes things a bit quieter, probably because it's the rubber in. It's just applying my stuff that I learnt when I did my audio engineering stuff about sound proofing. Basically, different densities of material interrupt the vibrations, which should mute the sound somewhat. So obviously over a wooden board built on a box like this, you're going to get quite a big vibration. Once you put cork down, that is a different material, so therefore the sound wave will change as it goes from the cork through into the wood, so that should quiet it a bit. And then this rubberized one should change the sound wave a little bit more, so it should reduce the sound. Now if you listen to the engine as it goes round, see if you think it makes a difference. In here I think it does. So let's just start the train up again, and you'll see when it comes on there, and you'll hear when it goes off over here. I think it might take a bit of listening. So hang on, here we go. Let me turn the train round. You see, I think it goes quite higher pitch there, so slightly quieter. Obviously it's still noisy, but I think that, you know, over a sustained period of time with the number of trains running, it will help a bit. So there you go. That's I'm going to be using this rubberized cork, I think. So let's cut it into strips and stuff. So okay, that completes the experiments for today. So there you go, that's what happened. I'm quite pleased that it worked. Obviously I think I probably need a shunter or something with a short wheelbase to go across just to check, but unfortunately I haven't got a shunter, so at the moment I can only try my Deltic. But I can't find shunters in N-Gage anyway that are DCC ready, let alone DCC chipped. So without forking out a load of money, which I don't have at the moment, so I'll just have to assume that it'll work. It's not that important. It's in an area that I can take up. If a small wheelbase engine won't go across, I can just take the track up and change them for powered frogs or whatever in the future. But at the moment it doesn't matter because I haven't got any shunters, as I said. I do like shunters and hopefully I'll get some, but I need to find somewhere that does DCC ready shunters at a price I can afford. Okay, so that's it for now. Thanks for watching, and I'll see you on the next update. Bye.